All right, so for this problem, it says Kara and Lindsay both hike in separate directions from their campsite. So with Kara hiking straight to the east and Lindsay hiking straight north at 2 p.m. Kara hiked twice as far to the east as Lindsay did to the north. At 2:30, Kara covered another mile, while Lindsay had covered another half mile. If X represents Lindsay's distance in miles from the campsite at 2 p.m., what function could be used to represent the area of the triangle? Man, that's a crazy problem. So what I like, and most people don't know, is that a student asked me a very good question. They said, "Wow, there's no picture, right?" So let's start unpacking this a little bit. Just because it doesn't give you a picture doesn't mean that you can't visualize it. So what I'm going to do is I'm going to draw my own picture. So the first thing is, do you guys remember how to do the compass thing? When it comes to directions, north, east, south, all that stuff? This is a mnemonic. Never eat shredded wheat. You're welcome. I got to teach you kids everything. So now let's unpack this and then we'll draw our picture. I think my picture will be a triangle because we have to find the area of a triangle, right? So it says Kara and Lindsay both hike in separate directions at their campsite. Kara is hiking straight east. So this is Kara's path. Okay. And then it says Lindsay is hiking straight north. Well, that's not exactly straight. We'll try it. We'll do our best. This is really kind of hard to do. All right. So that's Lindsay's path. And they start at 2 p.m. Kara hikes twice as far as Lindsay to the north. As Lindsay hiked to the north. At 2:30, Kara had covered another mile, while Lindsay only covered a half a mile. X represents Lindsay's distance. So we don't know how far Lindsay went, but she went X. I'm going to write that down over here. So we're going to say that Lindsay went X miles. Okay. And then now we got to figure out what Kara did. So let's reread it again. It says Kara and Lindsay both hiked in separate directions on their campsite. Kara went straight east and Lindsay hiking straight north. At 2 p.m., Kara had gone twice as far as Lindsay to the north. At 2:30, Kara covered another mile while Lindsay covered another mile. So let's talk about this. At 2 o'clock, I'm just going to make a little mark here. This is 2 p.m. and this is 2 p.m. All right. It says, oh, we got to be careful. Okay, I got it now. It says her distance is X at 2 p.m. Okay. So we got to think about that. Well, Lindsay didn't just travel X because at 2:30, Lindsay had covered another mile. So Lindsay actually went X plus 1 because X represents how far she traveled at 2. Whoops. So by 2 o'clock, she traveled X. And then at 2:30, she tacked on another mile. So that's how far Lindsay went. And then Kara went at 2:30. Let's read where Kara went. Kara had covered another mile. Oh, no, my bad. Lindsay only went a half a mile. And I'll show you where I'm getting this from. So here it says Kara covered covered another mile. So Kara went twice as long as Lindsay, 2x. This is her 2 p.m. stuff. And I'm unpacking it, but I'll explain it in a second. And then Kara went an additional mile. And then Lindsay went another half mile. So let's talk about this one more time. This is how you do these types of problems. They're really kind of hard, but they're not. Okay, so Kara, from the beginning, Kara and Lindsay both hiked in separate directions from their campsite. Kara went straight east, while Lindsay went straight north. At 2 p.m., Kara had went twice as far as Lindsay. But down here, we know that Kara went twice as far as Lindsay, but they said that X represents Lindsay's distance in miles from the campsite at 2. Okay? So really, if Kara went twice as far, it looks a little bit more like this. Let's say that Lindsay went this far. This is her 2 p.m. Well, Kara went twice as far. This is her 2 p.m. Now that is 2 times X, right? It's twice the length of Lindsay. Now at 2:30, Kara went another mile. So this is the plus 1 mile. So this is where she was at 2:30. But Lindsay only went a half a mile. So this is that half a mile right here. Now it's not drawn perfectly to scale, but so what did Lindsay do? Well, at 2, she went X miles, and then by 2:30, she had gone another half a mile. Well, at 2, Kara had gone twice as far as Lindsay, 2 times X, and then by 2:30, she had traveled an additional mile. Whew. Now the question is, and by the way, this is the campsite right here. The question is, what expression, what function could be used to represent the area of a triangle that the girls formed at this campsite? So what they're saying is, look, the girls formed kind of a triangle, right? This is Kara's path. This is Lindsay's path. And what's the area of this thing? Well, the area has a formula, which is 1/2 times the base times the altitude height. Because Kara went due east and Lindsay went due north, the height is really Lindsay's distance, and the base is really Kara's distance, right? So this is like really the height of the triangle, and this is like really the base. So now what I'm going to do is I'm going to say the area of this thing is equal to 1/2 times the base. What do I plug in for the base? 2x plus 1 times the height. What do I plug in for the height? X plus 1/2. Whew, that's a lot of work. So now I got to multiply my 2 binomials to get my quadratic. So yeah, it's a lot, isn't it? I'm going to multiply 2x plus 1. By the way, on the SAT, you got to do this in 60 seconds. Now, there'll probably only be one of these because they try to be mindful, but man, that's going to take us a lot. So then this is x plus 1/2. All right, multiply the row by the column. What's 2x times x? 2x squared. What's x times 1? X plus 1x. What's 1/2 times 2x? Just 1x. What's 1/2? What's 1/2 times 1? anybody know what that is? Yeah, it's 1/2. Thank you. It's 1/2. Okay. So all that stuff, if I combine the like terms, all of that stuff, I'm going to tack on this 1/2 right here. But all this stuff is equal to 2x squared, right? Plus 2x, right? I'm going to add this 1x plus this 1x plus 1/2. Now, I can distribute this through the parentheses. So what's 1/2 of 2? 1. So this is just x squared. What's 1/2 of 2x? Just x. Now, what's 1/2 times 1/2? What's 1/2 times 1/2? You multiply across. What's 1 times 1? 1. What's 2 times 2? 4. Now, I'm going to let you in on a secret. If I plug this in the calculator, it's going to be 0.25. Now, the reason I say that is when you go to do this problem online, it actually has it written as a decimal. Okay? Normally, I would want you to leave it. So that's the final answer right there. All that work to get that little expression. Okay? Any questions on that one? Well,